Okay, guys, we're on to number 5 on our review, so page 2. If you look at this first set of equations, you've got y equals 3x minus 4. Okay, that if you're still looking at y equals mx plus b, I'm going to put that here on this page 2. Your m, which is your slope, is 3, and your b, which is your y-intercept, is negative 4. When I plot that here, I start with my y-intercept, which is negative 4. And then remember my slope, okay, this is my slope over here. That is my rise over run. Okay, so if I start here at negative 4, I go up 3 over 1, up 3 over 1, up 3 over 1. Okay, so this is what my line kind of looks like. I don't have a straight edge, so I'm doing my best here. Okay, that's the line for that first equation. Okay, now I'm going to take a look at my second equation. Let's see if I can get a different color here. You have got y equals negative 1/2 x plus 3. Okay, so my slope is negative 1/2, and my y-intercept, b, is 3. So I start here at 3 as my y-intercept. I know it's a negative slope because it's going to be downward sloping. So I'm going to go down 1 over 2, down 1 over 2. So here you go. This is my line. Oops, again, not a perfect line, but it's hard to write with this pencil here. Okay, so now the solution is the intersection of those two lines. Excuse me. So my intersection is, my x value is 2 for that point, and my y value is also 2. So the solution to my system of equations is the ordered pair 2, 2. Okay, so that's pretty simple. Our next question, number 6, is what is the equation in point-slope form of the line that passes through point negative 2, 3, and is perpendicular to the graph y equals 1/2 x minus 1. Okay, so there's a lot going on here. It's actually pretty simple if we break it down. So I'm going to start out with, okay, they're asking us for the equation of a line in point-slope form. Okay, so you will be given these sets of formulas. Point-slope form is just that. It is a form that has a point. Okay, so I'm going to write that down. Point slope. Okay, the point is x1, y1, and the slope is m. Okay, so when you are given this equation on your formula sheet for your test, point slope form is y minus y1 equals m, which is your slope, times x minus x1. Okay, so you're given the formula on your formula sheet for your test, okay, and we just need to plug things in. Okay, so they tell us here that our point is negative 2, 3, so that means that is my x value and my y value, okay, my x1 and my y1. And then the other thing they tell us that it is perpendicular to this graph right here, or this line, y equals 1/2 x minus 1. Okay, so I'm going to change colors up for a minute and change this into green so we can show that this is this particular line. Okay, for this particular line that they've given us, they are telling us that the equation that they want is perpendicular to this guy. So if I'm looking at this guy right here, y equals 1/2 x minus 1, the slope of that line is 1/2. Okay, but I don't want the slope of that line. I want a slope of a line that is perpendicular to that line. Okay, so a perpendicular slope, I'm going to write it over here, a perpendicular slope would be the opposite reciprocal, which would be negative, oops, let me fix this, okay, would be negative 2 over 1, okay, because perpendicular lines are opposite reciprocal. Okay, which means opposite, if one is positive, the other one is negative. Reciprocal means I flip my numerator and denominator. So if, again, your slope of the line they gave you is 1/2, then a slope perpendicular over here would be -2/1. Okay, so now we have everything we need to input the information into our point slope form. Okay, so I've got y, oops, let me get this going again. Sorry about that, I'm having trouble with my pen. Okay, y minus my y1 is my y value, so that's a 3, equals my slope is -2/1, or just -2, and then x minus my x1 value is a -2. Okay, so to simplify that or make that proper term, -2, see this becomes a +2. Okay, so the equation that we're looking for is y minus 3 equals -2 times x plus 2. So this is my final answer. If you need to stop and rewind, go ahead and do so. But basically, just don't be intimidated by a problem like this. Read through the problem, see what they're asking you for, look at your formula chart, and write that down. Okay, so backing up again, take a look at this. Point slope form. Okay, I went ahead. This is my point slope form. This is what's given to you on your formula sheet. Okay, the y1 and x1 just represent the point that they give you. And then the m is the slope. Okay, that is point slope form. And then they gave us this equation right here, y equals 1/2 x minus 1. And they told us they wanted a slope that was perpendicular to that line. So this particular line had a slope of 1/2. One that would be perpendicular over here will be the opposite reciprocal, which is -2. And then I just plug everything. I plug in my 3 from my y value. I plug in my -2 from my x value. And I plug in my -2 for my slope. And I'm done. Okay, pretty simple, straightforward. Don't be intimidated. Okay, our next question on our review is number 7. It says, what does it mean for a system of equations to have one solution? Okay, that's pretty simple, pretty straightforward. One solution just means that two lines intersect at one point. Okay, and that one point is usually in an ordered pair, an x and a y value. Okay, so as to give an example, let's just say, for example, I'll give you an example here. If my solution were 2, 3, that would mean that my x value is 2, my y value is 3. Okay, so if I come over to my graph over here and I'm looking at the point 2, 3 as being my solution, I'm going to go ahead and plot that point. 2, 3, let me see if I can make this a little bit bigger. Okay, 2, 3 would be something like 2, 3 is this point right here. Okay, so if that is the solution to my equation, I can have all kinds of lines. I can have a line that looks like this. Okay, and then another line that looks like, come on now, green, here you go. Another line that looks like this. Oh, goodness. The pen's acting up on me. I apologize. Okay, but it looks like, there you go, that line. Okay, so that would be an example of an equation having one solution. Okay, two lines that intersect at one point. Okay, so you got all kinds of different examples you could have. Now my next question says, what does it mean for a system of equations to have no solution? Okay, no solution means that the lines do not intersect. So if I write that down, lines do not intersect. Okay, basically these are parallel lines. Okay, and if we remember, parallel lines have the same slope. Okay, so an example of that would be, this would be one line. And then if I draw another line here, a line that's parallel to that, okay, that would be an example of a system of equations that have no solution. Okay, so that covers us for the second page of our review, and we will get started on the third page right now. Thanks a bunch. Bye-bye.